In this video, I'm going to talk about isomers, and isomers are a structure that you can draw multiple different ways. They're kind of like synonyms. They have the same meaning, but they have a different organization. And then later in this video, I'm going to talk about cis and trans. And cis and trans is a way that you label these isomers to indicate how they're put together. So if I asked you to draw me an isomer for H12, you could draw any arrangement of 5 carbon in a row with their hydrogens fully saturated. You can have a straight chain version with all 5 carbons linked up in a row, and you can have 4 carbons and 1 branch. You could even do 3 carbons with 2 branches, and they all will have a structure of C5H12. Those are called isomers. They're structural isomers. They all have the same formula, but they all have different appropriately named names indicating how they're built. For instance, pentane, a single 5 carbon chain, would be N-pentane. If you did the 4 carbon chain with 1 branch, that's methylbutane, 2-methylbutane we could call it. They also call it isopentane. Or we could have a propane with 2 methyl groups on here, so this would be 2,2-dimethylpropane, or it's also called neopentane. Cis and trans are different. This would be when you have a carbon double bonded to a carbon. In a carbon-carbon single bond, these bonds can rotate, meaning the carbons can spin 360 degrees around the bond. But when you have a double bond here, you can see that this would never rotate, because if you remember building it, they don't spin around the central axis because they have 2 connection points. So what happens is that if you have different things built connected on the top and the bottom to finish filling in the carbon's valence, if you have different things, you have different arrangements. For instance, you could have a cis arrangement where you have things on the same side. And if you have a trans arrangement, let me show you in a different color. If you have the trans arrangement, these are opposite sides. So when you are talking about a cis arrangement, you're talking about the branches or even the carbon chains are both going to be on the same side of the molecule. And so in this case, they named it cis-2-butene. The 2 references the double bond. So we have 1, 2, 3, 4. We have a 4 carbon chain, and on the second carbon we have a double bond, so that's the cis-2-butene. On this other one over here, we still have a 4 carbon chain, and we still have our double bond on the 2 spot, but our carbons are opposite each other, so that's why it's a trans-2-butene. So here are some examples of cis and trans isomers. You can see in this, we're going to look at this lower one first. You can see that in the chlorines are on the bottom, so they're on the same side. So we would call this cis-1,2-dichloroethene. Again, it is 2 carbon chain. It's a 2 carbon chain, and we have 2 chlorine groups, and they're on the same side. In this other example, it's a 2 carbon chain, so that's an ethene as well, but our branches are on opposite sides. So in this one, we would call it a trans 1,2-dichloroethene. And I see that they have an error in the example that I borrowed online. I would call this trans. Okay. In the examples up above, this one has a 1, 2, 3, 4, 5 carbons, and so this would be a pentane, and it is on our 2 carbon again. And because everything here, we're going to look here at where the double bond is. So do we have our branches or other carbons on the same side or opposite sides? In this case, they're opposite, so I'm guessing this is going to be a trans-2-pentene. Goodness, I'm moving all the wrong things. Hold on. And because I've now written over top of my boxes, I can't move my box, but this is a trans-2-pentene.